Hello and welcome to the channel. So we've got a WEM Clubman amplifier. This is from around 1965-1966. It's been in a loft for years, not been fired up. Front plate's missing. I don't know whether the customer's got that or not. And we've got power cord here, and we've got this cord, which I don't quite know what that's doing at the minute. So we're going to get the back off this, and we're going to sort this amp out, get it running again, get it recapped, and just check everything inside. Now I'm not going to fire this one up. I'm just going to get straight into it and find out what's going on with these first. Right, we're looking inside, and you can see this cable here is attached onto the side. This is that spur cable. The nails, you can feel, have come through the side just, so we've got some tacks in there, so we're going to remove that with the plastic caps, so they'll be gone for sure. And it looks like this can cap is a three sections, so we need to look at that. Power transformer is clipped onto the case of the amplifier. Oh no, it is screwed onto the chassis as well. So we've just got these at the side to get off, and we've got fixing nuts at the top there and there. Not much to it at all really, it's just a single-ended amplifier. Now that cap looks in good order, but it's been in there 60 years. So yeah, it's a long time. But we'll get it all out the case, and we'll have a look. See, we've got some connectors that's been put on here. A speaker. So that's an L Pico speaker, and they're not great, to be honest, but it is what it is. It's a very old amplifier. We've got some codes on the speaker, but I don't really do codes. Some people have got a massive knowledge in them. Can't quite read that one, it doesn't look very clear. But anyway, aside from that, look on the transformer. You can see we've got a date code there, or it looks like a date code, although 1963, do you think? But we know this amp's later from the history that I've looked at online, but it could be an old transformer they had in stock. The case has changed over the years, but I doubt very much the gubbins inside have changed much. Code on the speaker there, but as I say, if you look at the first digit there, it looks a bit smudged. And there's another code there for anyone who's counting the codes. If all those codes mean anything to you, and you know they tell you more about this amp, let me know in the comments. So you can see there the fleshy cap there, got 130 ohm cathode resistor on the output tube, which is an EL84, and I think that is, does it look like 50 microfarad? It is 50 microfarad. And we've got another one here. If we go up, should be able to just see that. And we've got another one there that's 50 microfarad. It's got a mustard cap as well, so if we just go up, you can see there, mustard cap, and that looks like it's coming off. I'm not sure where that's going. And we're off one of the volumes, maybe. Let's just see. Well, it's coming off the jack socket, that one, off one of the inputs. And then we've got another one just there, you can see, just go up slightly, and that's coming off the volume control there, which is 500k by the look of it under the solder. Sorry about that. You need to move the camera very slightly when you're zoomed in at 7.9. We come down, you can see the can cap there. We've got 3 sections, red, yellow and green, and then we've got the ground on there at the top. We've got a capacitor here. We just go up, and that is 5 nanofarad, 0.005. So yeah, 0.005, 5 nanofarad. Yeah, and that is an aeroplane that you can hear because I'm outside again. Pink's got a new den, as you can see there. Every cardboard box in this house has to be vetted by Pink, and it can be thrown away when she's finally finished with it. So there's the date code on the output transformer. I presume it's the date code anyway, but again, let me know in the comments. They're very rare, these amplifiers, very rare. They didn't make many. So let's just go back. You can see it in its full. Now it's out of the cabinet. Original Mullard tubes, I think. Looks like it. There we go. Oops. Don't seem to want to focus on that, does it? Original Mullard tube, L84. We'll test these. I bet they're good though. And we've got here, and they feels like that's never been out of there. EZ80. And then we should have a ECC83 12AX7 under here. Under this shield. And these shields are a common thing with these WEM amps, even on the later 70s ones, the Dominators and things. You see that's never been out of there. That just looks brand new, doesn't it? Gold. So we'll test those. You can see the can cap, and we're going to have to change that. It's been in there a long time. You can't really leave that, and it looks fine, and I dare say it'll test fine, but if that was to go short, takes the power transformer out, pretty irreplaceable on this amp. Right, I've got the tube tester. So we've got this L84. The pins will need a bit of a clean, but I think we'll be okay for testing it. Let's see. And there we go. So not 100%, but because these Mullards usually test on this somewhere around 90, 95, but that's still pretty good. There's plenty of life left in that. Plenty. Let's try the 12AX7 next, ECC83. And we want 91. Flick all these back. Three and 8. Excuse the traffic going by. We're doing a Shango again, working outside. Yeah, he's okay. and 8. A little bit better on that section. He's fine. Right, I need the book to get the settings for the EZ80. That one I can't remember in my head. There, oops, got hold of that. EZ80 5E1, and then it's 7 and 1 for the test. So pretty easy, that one. 5E1. These usually test pretty good, so go for 1. Last year's these tubes, and we're on the bottom, and we're on the bottom. See, diode's okay. He's absolutely fine. He's a lumberjack, and he's okay. So the tubes are bang on, so that's good. Right, I've got the bulb out there on the pilot light. We'll give this a test, and I'm just using this analog. Whoops, there we go. I'm just using this analog meter outside because it's a bit bright for the screens on the digital ones. It'll do for just this sort of testing. Bulb's fine. Right, it's gone a bit cloudy now, so we're going to quickly test these resistors. There's not many of them. So 130 ohms. That's the cathode resistor for the output tube. Stop it, Pink. We're trying to do this, and you're harassing me for food and knocking my hand off the terminal. I'm going to get bit in a minute for not providing service. Pink, you're being a pain. You probably can't see her off camera, but she's pushing her head into my hand, and that's not fun when you're trying to get the probes onto the said points. Well, that's okay, nothing wrong with that. There's a 10k here. That's on the grid, so that'll be a grid stopper. 10k, so we can get a reading on that. Whew, bang on. Bang on. 47k. That's near enough. 470k, is that one? Is that the grid leak? 462, that'll be fine. 23k, sorry, reading that back to front. 3.3k for that. That's probably a cathode resistor for the preamp tube. Yes, because of the capacitor there. Let's just clip the capacitor because we're changing that anyway. Is that the one? Is that? Let's just have a look. Yes, it is. Yeah, so that'll be the cathode. Be a cathode resistor for the 12AX7 there. So let's try again now. Should make it easier to test, and he is over a fair bit. So we'll mark him down as being changed. So we've got some plate resistors here and here, but I think we'll change those anyway. We don't want it back frying in a couple of months, although they test. That one tests okay. So does that one really, but don't see much point in leaving those in there. We've got another resistor here, 100k. What's that resistor doing? Pin 1, pin 2. That's going to the grid, so that must be a grid leak. Then got 1 meg here. That'll Can't get a reading off that, can we? Because it's grounded. Because we haven't got. We don't have a jacks plug in there. 476, 47.6. That's 47k, and there's another 3.3 at the back there. So we'll clip that plastic, because I know those plastic caps will be no good. I've never found one yet that is. Been mugged to leave those in there. Some odd ground points. 3.5. I think we'll probably change both of those. So we'll change those. Change that one. That's about it, really. There's not many more, is there? Needs a little bit over, but not massive, is it? So they're quite healthy, those resistors, really. Pretty healthy. Just change the plate resistors for precaution, and just change the cathode resistors on the 12AX7. Change these plesses, which are all 50 microfarads. Another one tucked in there. I presume that's the same. Now, what we're going to do about this, we need to get that out first. So we'll cut these and remake them. And yes, I haven't looked where they go, but it can't be that hard, can it? It's only a single-ended amp. It's not a massive job. Now we need to get that can out of there. And to do that, I don't think this screwdriver will do it. No, it won't. Try this one, see if it's loose. No, it's not. Alright, so let's have a look at what we've got here. That's the wrong one, I think. Oh, is it? No, it's not. I just can't get it in for the bracket. Right, I think we'd better get some WD or something on that, or some oil. It's a bit rusty, isn't it? Cap out, and it's 2020 350 working volts. Surge 426. So there's a code there, EP7104, for anyone who's counting the codes. So we'll go 3232 on this one. Right, I'm just going to film this in here. You'll have to bear with me. I've put the washing machine on and the pause button doesn't work on it anymore. So yes, we'll just plod on from here. So let's have a look then. I've laid this out. So remember, we had a 3-section cap. Now we've only got a 2-section cap. We've added this cap here, and we've put this tag strip on, and we've used what I've done is I've put it onto the bolt of the capacitor bracket, and I've put a nice star washer on there to get that nice and secure. Got a 22 microfarad at 450 volts, so that's absolutely fine. So we've gone 32 32 22 instead of 20 20 20. Now I could have gone 50 microfarads, but not with the EZ80. It's probably not a good idea. So 32, we've still upped it, and it'll still, obviously it'll make it, but it won't have as much background hum. 22 microfarad, probably have a bit of background hum, but that's improved things, so that's good. The 47k, I've dropped that down to 10k, because on some of the later Clubmans that was dropped to 10k, and 47 seems a lot for a drop-in resistor from screen to preamp tube in a small amp like this. But there's something that's missing on there. Have you spotted what it is? Something that's not there. There's no drop-in resistor between node 1 and node 2. Now, I kind of looked at that for a minute, and then I twigged what was going on with it. So this is the screen here on the EL84, and if we just pull that over, you can see that there's 2 wires on there. So obviously one of those wires goes to this cap here, but if we turn this over, we follow that wire, it goes up to here. And the dropping resistor, if we just look, we just pull this up so we can see the dropping resistor is there, and it's 2.2k on this one. Normally the 1.5, but that's fine. So it looks really healthy, and I tell you what, I measured that and it was exact, it was spot on. So I'm leaving that. Now this, on the other hand, this Zobel network, as some people call them, it's to stop spikes on the output transformer. And look at that resistor, it's burnt, so that needs to go. I'm afraid we're going to have to change that. That's pretty charred. I'm not sure why that would be. I've never seen one of those like that. So it's a little worrying, that is, why that is like that. I'm not sure, but that's something we need. Maybe the capacitor's gone dicky, so we might just actually, what is that? Well, it's 400 volts, so maybe that capacitor's gone dicky. I don't know, and that's what's caused that. But we need to have that off, and we'll check that obviously before we power this amp up. We really do need to check that. So that's where we are. I've changed the bypass cap on the cathode resistor to 47 microfarad. And if you wonder why we've come indoors, it's because the sun's out and it is a bit fierce out there. We're just waiting for the sun to go around and we'll be back outside again. So yeah, so we've changed that, and I've not soldered these up yet either, so just move this out of the way. I've not soldered these up yet, they're all just in place there. So if you remember, the only resistors that are out of tolerance was the cathode resistors. I've snipped one of those out, the other one is there, and there's the bypass cap for it, so we're going to change that as well. These 2 plate resistors are going to be changed. Then what we'll do is, when we get everything sorted out and that charred resistor, we'll fire this up, and then we'll check for leakage on these coupling, these coupling caps. There's one here, one here. We've got to clean the tube sockets, clean the pins on the tubes, because they're a bit grabby. But yeah, not much else. Now there's a couple of resistors on this transformer here, one there and one there, and they are 54 ohms. Bit of a strange value. You can't read the value, but I measured it at 54 ohms. The other one's 54 ohms as well, exactly, and they are the virtual center tap for the filaments. That's what those are. It's a virtual center tap. So yeah, we're gradually getting through this amp, checking everything, making sure everything's right. So right, we'll press on. Right, so they've took this gadget off here, this anti-spike, whatever you want to call it, to protect the transformer. That measured at 470R, so I put a couple of 1Ks in parallel to make 500 ohms, which is near enough for this. And then we've got a new I thought I said that resistor was 4,700 picofarad, but this one it's not, it's actually 2,200 picofarad, 2.2 nanofarad, which is what we've done there. So we've installed that. Now this drop-in resistor, which is 2.2, which is 220 ohms. I said that were 2.2k. That's my eyes again, missed that. But did I measure that at 2.2k? It's a bit singed. I didn't notice that till I put the bigger glasses on and had a look. Pulled it up and you can see it has just had a bit of heat. That's 220 20, well hang on a minute, 22 ohms, that's not saying 22 ohms, is it? 2.2k, look, on the meter. Can you see the meter there? Henchman Dregs, oh you can't see the meter there. Henchman Dregs is knocking the camera. Let's just zoom out a bit. Now you can see the meter. I think we need to disconnect that to test it, because that says that is red black, which is 22 ohms, but it measures 2.2k and it's a bit charred. It's very strange, this, because it's like this is an ultra linear tapping for these screens. We've got centre tap here, and then this wire here is going to the plate, that's the yellow wire of the EL84, and then we've got this tap in here through this resistor going to the screens. Or has that just turned black because it's had a bit of heat? We'll have to disconnect that and examine it, I think. So we've got all the other resistors fitted and capacitors fitted. I think we'll cut that, it's no good anyway. Let's trim it. Make that easier to get off. Right, now we've got one leg off. Let's measure it again. Out of circuit. Makes sense? Think so anyway. My eyes, let's see this meter. The light shining on it, let's have a look. 2.2k. Well, if that's gone up in value from 22 ohms to exactly 2.2k, I'd say that's a miracle. And the more I look at that, I think that's, yes, I think that's a bit charred, madam. Yeah, I think I can just see a little speck of red there. So I think we'll change that. It's about 2 watts, that, isn't it? Tested this capacitor, the one that came off this one. Right, so I'm sat below the camera. This one, and it tests okay, but obviously when it's under load and it's got voltage on it. So if that goes to ground, so if that was short or leaking, then that may be why this resistor's a bit charred. Right, I'm going to look for a 2.2k resistor. I'm going to feed pink because I don't want to dabbing a nose on the end of the soldering iron while we're soldering it in. Yes, I think we're ready for a new fuse, and I've cleaned the fuse holder as well, giving it a shine with the wire brush in the drill. And just a thing that when I showed you this capacitor, the insulation has split on it, so we've got another one in there. That'll come in handy for one of my amps, but we're not putting it in a customer's amp. So we are ready to fire this up. It's a bit tricky because can't really have it flat because of that EL84 sticking out, and the last thing I want to do is break the pip off the top and then it goes to air and it's all over. So we're just going to persevere with it stood on its end. It's about the only thing we can do with it, really. I'm going to bring this up on the current limiter. Now I have got the rectifier tube in here, which will take a bit of time to warm up, so on the bulbs. Ah dear, look at that. Someone's, why can't I get that to focus? Someone has melted the power cable at some time many years ago, and I didn't spot that straight away, but obviously I thought I'd just check the power cable before we start. And yeah, so we need a new power cable, but it'll do for testing. Right, so we're plugged in and off we go. So we won't see anything on the meter yet. We've got 60 volts and climbing going into it. And we're drawing 40 milliamps. Obviously some of that is the bulb. We've only got a 15 watt bulb in it at the moment. We're just taking us time with it because we don't want to blast those capacitors. We need to catch it in time. So we've got, you can see that going up now. There's going up slowly. It's in millivolts at the minute, 355 millivolts, and you'll see that begin to climb. 99 volts going into the amp. Turn all the volumes up, and while it's warming up, we'll put the cable, the signal generator, we'll plug that in. It's going on there. Pilot light is lit, drawing 90 milliamps, but we don't seem to be we don't seem to have any so I wonder if that let's just check the, see if we can see any filaments on that rectifier tube. Can't see any. Thought we'd have some power now. Well, I tested the winding, and there was definitely resistance there, but that doesn't seem to be wanting to warm up, and there's 156 volts going into it now, so unless that meter isn't registering for some reason. Well, there you go, the meter's not registering, that's what's wrong. I've only got 178 volts there, so let's see if we can find out why that is. Is it something to do with these these tubes. Oh yes, there we go. So it looks like those, I've not used those on those meters before. It looks like they don't like the sockets very much, those. But we're away, that'll do us. That'll do. That'll be sound. 178 volts going into it, but we don't have any sound at all. Just a tiny bit. And I'd expect to have some sound. So we've got a problem somewhere. Oh, I can hear sound coming out of speaker. I just can't hear this coming out. Oh, how odd. We better do some testing then. It's quite difficult because the camera is right in front of this this amp, and it doesn't give me a lot of room to work because of the way we've had to stand it, and obviously, you know, the camera's not above it. It's kind of yeah, whatever. But we've got plate volts, at least. I can see that clean enough. Well, be HT voltage anyway. I presume we've got plate volts, but we shall test. Leads back in this meter and have a bit of a probe round. Still on the 40-watt bulb. Let's test round and see what's working and what isn't. So 3.74 across the cathode resistor tells us we've got conductance of the output tube. We've got 170 volts on the plate and 170 volts on the screen as well. So I think that transformer is ultra linear, and that 2.2k resistor I think is just like a screen resistor. So that's working, so we know the output tube is working fine. So now let's go to the plate resistor. So this is the feed for both plate resistors, and we've got 168. Let's go to this one. 141. Let's go to this one. Where are we? I'll just get into that. So let's see there, and we've got 166. So that triode is not conducting because we've got the same voltage on the pin of the tube as we've got on the feed of the two resistors. So that is pin 1, and this cathode resistor here is the cathode resistor for that triode, and there's nothing across it at all. So have I wired that up, soldered that and wired it up correctly? It looks correct. Let's just try the other cathode resistor. We know that side is conducting, don't we? And yes, we've got 0.8 of a volt going across there. So something wrong. Is that tube tapered? I hope not. That would be a shame, wouldn't it? But I think that's the first port of call. Let's remove that 12AX7 from there. That will be disappointing if that's gone. It will. Very disappointing. The tube in there. And there we go. So sadly, that Mullard 12AX7 ECC83 is down on one side. What a shame. What a real shame that is. But that's the luck of the draw, I'm afraid. Pots want cleaning, obviously not done those yet. I don't, if pots don't need cleaning, I don't spray anything into them. But that needs cleaning, but other than that. Right, let's just check across that cathode resistor again. And yes, 0.759. So yeah, what a shame. That really is a shame. It's never a good day when you find a Mullard preamp tube that's blown. So all's looking pretty good. The pots need cleaning. We need a power cord on it now. Sass and Rass and Sass and Dick Dastardly. Right, let's go up a bit more. We don't go too mad. Just stick another 15 watts in there. So we've got 55. Let's knock that off now. And we'll just quiet at the moment. That's flat out. It's only got a bit of a junky Chinese test tube in at the moment. Nothing major. You can see now we've got 200 volts if you're looking at the meter on the right, drawing 110 milliamps. So all is looking very good. Right, we're going to take a bit of a jump up to 100 watts now. So 100 watts of bulbs. And that's pretty quiet. The amp's flat out. And already these pots have cleared. You know, they're not that bad. Always best not to spray stuff into them if they don't need it. But we'll probably just give those just a bit of a swage because they were. But look at that now. Huh. Well, what can you say? So 245 volts. Now normally I'd be testing to see if we got any leakage on those capacitors with that Mullard preamp tube being in there, but as we've only got some junky Chinese tube in there, second-hand junky tube, we'll just take this up and then test it when it gets to full voltage. It's looking good, looking very good. So I think now we'll go up a bit more on the bulbs. 140 watts of bulbs, and we should be soon getting to full power because we're at 224 volts with 140 watts of bulbs, and we're doing 150 milliamps. So what we will do is do a bias calculation on that output tube and just make sure it's not getting cooked. So we'll go back onto this meter and we'll measure across the cathode resistor. Remember, we're still on the bulbs and we've got 6.39, so that looks healthy. And it's 130 ohm resistor, and we know that resistor's on the nose, don't we, because we measured it. So forgot what I said now. I'm chewing away on this chewing gum. If you notice that I've been chewing gum of late, I'm sorry about that, but I've got acid reflux and it helps massively with it. I actually don't like chewing gum, but it's so effective. Obviously I've got tablets for it, but yeah, it works a treat. So anyway, enough waffling. So divide by 130 ohms. Wow, is that right? That 6.36 divided by, that is 130 ohms. Yeah, 130. Yeah, 130 ohms. Well, that's 49 milliamps. That seems a bit high to me. So maybe that voltage drop isn't okay, and maybe that could be why we've got some swagey resistors. So let's see. Shall we? Plate to cathode. And there's 236.5. And that tube's already at 11.5 watts. I didn't take 5% off for the screens, mind you. Mine, of course, it's single-ended, isn't it? So we're probably going to have a bit more current draw on it than we would normally as well. And we've not got a lot of plate volts either. But we will have a little more. Right. Let's up the bulbs massively. So we've got 250 watts of current limiting now. 232. So let's just check that again. I don't want to just slam massive current onto that, although we're about there now, but it'll still be restricting it, the bulbs. Now got 6.8 volts there. .3 milliamps now. Let's just take away 5% for the screens. That still leaves 49.6. 249 volts. 12.3. So that tube's getting a bit of swage. It is. An interesting comment actually from Rob. So we could do with a swageometer, which I thought was an excellent idea. However, someone rather spoilt it by leaving a bit of a harsh comment, asking Rob what he was talking about, but the gentleman in question who left it slotted the F word in there. So I wrote him a polite comment explaining that we don't talk to people like that on this channel, and gave him the option to delete it before I did. However, he didn't delete it, so I had to do. So if you read that comment, Rob, I'm extremely sorry for that, but yes, I'm not having that. We all talk to each other with respect because it's a community. Anyway, enough waffling. So yes, I'm beginning to think that we're going to be a bit over biased with that tube. So if I now come off the current limiter, we're drawing 160 milliamps at 236 volts going into, that's what's going into the amp off the wall. Now bear in mind that that will be at, well, it's down to 235 now. Bear in mind that'll be at 241 later. Now got 6.88, so it's not gone up a great deal, has it? Because, as I say, those this doesn't draw a lot of current, and 250 watts a bulb is quite high for this amp. So 6.88 divided by 130, that's 52.9 milliamps. Let's take away 5% for the screen. 50 milliamps that tube's running at. Right, let's get another reading. 250 volts, that's the max that's going into it, 250. 12.5 watts, so it's acceptable. I think when the voltage gets up to 241 it'll be at 13 watts, so it is a Mullard tube, and they stand, that's not excessive really, it is a little bit over. And the problem is with this amp really is that if I reduce that bias significantly, this amp will be breaking up. You probably won't get a clean tone. It does tend to, if you lower the bias, it does tend to make them break up quicker. It won't be as loud, so it'll break up quicker. But that is just so quiet as well. Nice flat out. Hey, turn the volume down. That's unbelievable. That is so quiet. My word. So yes, so there it's running. It's all up and running. Even the pots have just cleaned themselves up. That's all right. That's because I switched it off. I keep going past the stop on the treble control. They're normally really noisy when the switch is on the tone control, but that, I bet you're lot struggling to hear that. And I'm sat right on the speaker. That's incredible. Right, we need to check to see if we've got any leakage, don't we, on those grids. That's the next thing. See if these caps are leaky. So I've got two of them. One is a mustard cap here, 191. Nothing on that one. And then we've got this Mullard cap, mustard cap is here. Nothing on there. So they can stay. They're very good. I mean, normally these we expect it, but this one, yeah, that Weimer cap is perfect. So there's no reason to rip those out. Looking good. So that's running excellent. Really well. There's some more tests we need to make though. Oh, just 10 volts across that resistor. That's nothing on a 10k resistor. Didn't need the 47k in there. 10k is plenty. Lets a little bit more voltage onto the plates of the tube, and that was changed on the later models, I do believe, to 10k. So we've got that going nicely on there. That's very nice. So the next thing I'm going to do is I'm going to put this amp on a dummy load, and I'm going to crank it with a 1 kilohertz sine wave through it, and I'm going to check those resistors that we had that were a bit singed, and I'm going to check that they're up to the job. Right, now I'd cleaned the pins on this Mullard tube, and I've cleaned them again, and I'm just going to put this back in because it did test, didn't it, on the tube tester. I just sat here thinking, well, that worked on the tube tester, so I'm going to swap it again, and I'm going to see if that still works. Clean the tube sockets as well, but I'm going to just give that one last go, because that is, I don't want to condemn it yet, that would be a shame. I'm just going to go one last try, and it won't do any harm to have one last try. Let's get that in there. You look at that, would you believe it? Well, I've really cleaned those pins as well, and I've just cleaned them again, and just so that something was just not seated correctly. So I wonder, with it having this on, whether it wasn't, if that was, and then the clip on top, whether that had just well, it didn't seem to do anything when I moved it around either. When I was testing it, that was off camera, when I was just, I thought I'll just give it a wiggle before I pull it out. But look at that. I just suddenly sat here thinking, well, it worked on the tube tester. Well, that's made my day. Excellent. Been a long day. Yes, that we will clean those pots. They are just a little grungy. Well, well, thank the Lord for that. Yes, it been a long day, and suddenly realised, I thought, well, it worked on the tube tester. Maybe there was something in this tube socket, in the pin on the tube socket. I don't know. Who knows? Anyway, it works. That's all that matters. It works. I think what we'll do is just check to see if there is a dry joint on there. If we just go in and have a bit of a probe round. Now you notice I've got these smaller capacitors on here. We've got some 47 axials, but they're 50 volts and not on the I don't put those on the cathode resistors. These are only 16 volts, and that's what was on it actually. Those pluses were only 16 volts, 16 working volts, and you know, it's plenty for these. So and there's only 0.6 of a volt across it either as well. Which is about right for a 3.3k resistor. So yeah, that's yeah, I'm really pleased now. I'm waffling, but I'm pleased. Right, we've got the amp cranked. Look at this meter. So let's start with the 2.2k resistor. And we have 64.3 volts going across that. So 64.3 times 64.3, so we square it, and then if we divide that by 2200, that's 1.87 watts. So that explains why that resistor looks a little bit charged, because when this amp's cranked, now if we turn the amp down and measure it again, and now I've only got 16 volts going across it. 16 times 16 equals, divide by 2200 is nothing. So 0.1 of a watt. So this is the problem when these resistors are added, and you would think that, you know, this was done obviously in a factory, that would be tested, but that resistor isn't big enough. If you're going to crank this amp, and someone's obviously been cranking on it at some time, it's been cranked up flat out, and that's why that resistor looked a bit baked. Now let's have a look at the other resistor on that whatever you call it, Nobel, what thingy majiggy, and there's nothing on that. So was that capacitor leaking? Am I getting on there properly? Yeah, so there's nothing on there, so that capacitor must have been leaky, seriously leaky, when it had got voltage on it, for that to be burnt like that. So yeah, but that, I'm afraid, that 2.2 has got to be increased. That is not enough. That is getting, see, that's flat out now. That's getting threepsed. Now these metal oxide resistors, you know, they'll obviously stand more than a carbon comp will. Now if we just turn off, that's red hot. Yeah, that's baking. So that's got to go, because you know, if you're doing this, if you're going to do these amps, you've got to work on the principle that somebody at some point is going to use this amp flat out. Now, on that speaker that's in there, it probably won't last very long, although it's lasted long enough. But obviously someone could put a really good speaker in this and then be cranking it flat out, which, let's face it, is what a lot of people do, and me included would be doing. But that resistor is not going to last, and I had a feeling that that was not up to the job. So he's going to have to be changed for something much more substantial, like 5 watts. As I said, when it's idling, when the amp's turned down quiet, it's not a problem. But that is regulating current, and it's regulating too much. Right, so I've got the 5 watt resistor on, and I've moved the ground onto the chassis there because it was on this bolt here on the transformer, and that's just a no-no. So yeah, so we can put this back together. This grip cord is absolutely shocking, so we're going to have to look for a way of getting this secure in the actual cabinet itself. So, but yeah, we're all done now, so we just need to sort the cabinet out. Right, we've got this back together, except the I've still got the power cord to address the cord grip for that, but and the back's not on obviously because I've still got that to do, but the amp's all in its case now and everything, and it's all good. We washed the face panel a bit there, just washed its face, and yeah, it's all good, so we're ready to have a listen. Sounds surprisingly good, that speaker, it's really nice. that's good. Let's try the other socket. That's a bit warmer. That's the rhythm. Yeah, that is really nice. What a tasty amp, and it's so quiet. You can't even hear it. That is just so quiet. What an amp. Rusty as ever, but yes, what a great sounding amp. So there we go. That's been I've actually really enjoyed doing that. It's been a fun project, that. So I just hope the customer's got this panel that goes on the front there. But yeah, what a great tool. So that'll do it for this one. So thanks for watching, and you all take care, and I'll see you all in the next one. Bye for now.